Greetings everyone. Welcome back to video lecture series on VLSI design. My name is Dr. Prashant Bachanna, working as assistant professor in the Department of Electronics and Communication Engineering at Institute of Aeronautical Engineering, Dundigal, Hyderabad. In the today's lecture, we shall be learning about the structure of the Mosfet. That is the structure of the MOS or structure of the Mosfet. That is the conductivity or the resistivity of the path between the two contacts, the source and drain, is already is altered by the voltage applied to the gate. So this device is known as voltage controlled resistor. So before we start our discussion to the structure of the MOSFET, so we'll see the transistors in the VLSI, that is in the very large scale integration. The transistors are integrated on this silicon wafers. So before after studying the structure, the transistors, you can see this wafer. So on these wafers, the transistors are integrated on the silicon wafer. So as you can see, the small transistors are there. So these are the transistors which are fabricated on the one side, top side of the wafer. So only, as you can see, this round slice here. So only on the top side of the wafer we can integrate the transistors, not on the side and other parts. Okay, so only on the top of this silicon wafer the transistors are integrated. So the most widely used transistors are the MOSFET. So these MOSFETs are implemented on the silicon wafers, which are used for those ICs are used for different applications. So we'll see the structure of the MOSFET. So as you can see, MOSFET stands for metal oxide semiconductor field effect transistors. So as you can see, the MOSFET is made up of mainly three components, that is metal, oxide, and semiconductor. So we'll see the structure. So the MOSFET stands for metal oxide semiconductors. So we'll see the structure of this MOSFET here. So MOSFET has 4 terminals. You have to remember this point here. The 4 terminals. One is the gate, source, drain, and the substrate. So the first part what we get is called as, this is the gate. So as the name itself it is indicating, it is made up of, the MOSFET is made up of metal oxide semiconductor, and this is the metal. And for this metal, this is the contact. This is the contact, and this is the first terminal, that is the gate terminal, which is made up of the metal. Okay, so then we have the insulator. Okay, so this is called as the insulator. So we use here silicon dioxide. So the first part is the metal here. This is made up of the metal. Okay, aluminum. Then the second is the oxide. So most commonly used, this one is the silicon dioxide oxide, and here is the insulator. Okay, so these are 2 terminals. Then after this, so here 2 terminals become, that is N plus. So P type MOSFET. So we'll take for example P type MOSFET. So in the P type MOSFET, okay, so these 2 terminals are called as the source and the drain. Okay, so these 2 things are called as, so these are heavily doped N type materials. Okay, heavily doped n-type electrons. Okay. So we have source, drain, and the gate. And in the p-type semiconductor, the source and drain are heavily doped with the n-type material, that is electrons. And p-type substrate are used as the p-type materials are lightly doped. So this is the fourth terminal. This is the fourth terminal, which is called as the substrate. Okay, and here we have one more contact. So the metal usually we use as aluminum metal. Okay, that is the first. So we can say that so this is the structure of the MOSFET. So it has four terminals. The first terminal is the gate, which is made up of the metal, aluminum, then oxide, that is silicon dioxide material. Okay, so gate, and so it has four terminals here. Four terminals: the gate, then source, drain, and the fourth terminal is called as the substrate. So in generally we'll take only source, gate, drain as a name, but it has four terminals: source, drain, gate, and the substrate. So this is the structure of the MOSFET, as you can see. And here we have thickness T oxide. Okay. So when we talk about the thickness of the oxide, what we use silicon dioxide, it is called as T ox. So T ox is called as the thickness of the silicon dioxide what we are using. Now the working of the MOSFET is, as the voltage increases, as we apply the voltage, as the voltage increases, okay, the electron density will increase. Okay, as we increase the voltage, electron density will increase, and the thickness of the oxide, T ox, so this thickness, what is it? This will reduce. So as we increase the voltage, okay, electron density will increase, and the thickness T ox will be reduced. So this is the basic structure of the MOSFET. And in this type, we have discussed the P-type MOSFET. So in the P-type MOSFET, the source and drain are heavily doped. So why these two terminals are heavily doped is because we will require a strong contact. So for the flow of electrons. So for this purpose, these two terminals are heavily doped, and the P-type materials are lightly doped. So such kind of transistors are called as the P-type MOSFET. So in the structure of the MOSFET, we have seen a P-type MOSFET. So we should remember there are four terminals are there: gate, source, drain, and the substrate. So as the voltage increases, the electron density will increase, and the silicon dioxide thickness will decrease. So this is the structure of the MOSFET. So now we'll see what are the different types of the MOSFETs. So the MOSFETs are divided into the four types. That is N-channel MOSFET, that is pronounced as N MOSFET. Then P-channel MOSFET. So in the N-channel MOSFET, we have N-channel enhancement type and depletion type. So again, in the depletion type, we have in the enhancement type, we have N-channel and P-channel. In the depletion, again, we are having N and P. So we are having N-channel MOSFET and P-type channel. In this, we have the first one is the enhancement type, and in the enhancement type, we are having N and P. Now the question comes: so what is the difference between these two? So as you can see, in the enhancement type, we are having N channel and P channel MOSFET. So in the enhancement type MOSFET, the channel between the source and the gate. Okay. So what is this source and the drain? The channel will not be established in the beginning. Okay. So there will not be any channel between the source and the drain terminal. Okay, in the enhancement type transistors, either it may be an N-channel MOSFET or the P-channel MOSFET. Whereas in case of depletion type MOSFET, the channel exists between the source and gate terminal. Okay, as you can see here, so this is the source and the drain terminal. So already the channel will be present from the beginning itself. So such kind of MOSFETs are called as the depletion mode. The depletion mode MOSFET. So again, in this we have two types: N-channel and P-channel MOSFET. So this was this was about the MOSFET, the types of the MOSFET. So wherein we have two types of we have enhancement and depletion type. In the enhancement type, we have NNP, and in the depletion type, again we are having N channel and P channel MOSFET. So now we'll see these transistors one by one. In the next videos, we'll be seeing about in detail about the complete structure. Here we'll see the overview of the N channel MOSFET. So already we have seen in the structure of the MOSFET. So it has 4 terminals: source, gate, drain, and this substrate. So this is usually when we say the terminals, usually we call it as source, gate, drain, but actually we should mention the 4th terminal also, that is substrate. Okay, so in the P channel, in the P type, in the N channel MOSFET, okay, planar. So this is the enhancement type MOSFET. As you can see, there is no channel between the source and the drain. Okay, so this is about the P channel. The difference will be here. The P channel, the P channel MOSFET, the terminals are heavily doped with the N plus material. So again, in the N channel depletion mode, so here the channel exists between the source and the drain terminal. Okay, so that is the difference between the N channel and the enhancement type and the depletion. As you can see, this is the length of the channel. As you can see in the depletion type MOSFET. So from the beginning only, the channel will be exist. The channel exists in the transistor. So as you can see, this is one more type, that is a P channel depletion type MOSFET. As you can see, here also the channels are the channel exists. So these are the types as you have seen. So now we'll see the symbol of the transistor. So as you can see, mainly there will be 3 terminals: source, gate, and the drain. Okay, so and this is the substrate one. This is the N type MOSFET. Okay, P type MOSFET, and this one is the N type MOSFET. Okay, enhancement. So this is a enhancement type MOSFET structure here. As you can see, there is no channel shown here. Okay, this is the N channel enhancement type transistor. That is a symbol. As you can see in the P channel, the difference will be the arrow mark. Okay, so the arrow mark here shown is towards the inside, and in the P channel MOSFET, the arrow mark will be outside. Okay, so if the arrow mark is towards this gate terminal, then it is called as the N channel enhancement type MOSFET, and there is no channel exist here. Okay, and this is about the enhancement type P type MOSFET here. Okay, so as you can see in the enhancement type, if the arrow mark is, if your arrow mark is towards this source and it is grounded, so this also we can represent in this way also. So the arrow mark, if it is outside from this source terminal, then it is called as N type. And if the arrow mark is here towards from the terminals, source terminal only towards inside, it is called as the P type. So these are the structures and the symbols of the transistors. So similarly, we can go for depletion type. As you can see, in the depletion type, we have shown the channel here with this line. Okay, so the same nomenclature will be there. If the arrow is outside of the source terminal, then it is called as the N channel MOSFET. Okay, if the arrow is outside, it is called as N channel MOSFET. And if the arrow is towards the gate terminal, and here, as we have seen earlier, in the depletion type MOSFET, the channel between the source and drain exists from the beginning. So from the beginning only, the channel will be established in the depletion type MOSFET. Whereas in case of the N type MOSFETs here, and N type enhancement type MOSFET, there will not be any channel between the source and the drain from the beginning. Okay, so whereas in case of the depletion type, we have 2 types, N and P, and the channel exists between the source and the drain. So this was about the structure of the MOSFET and the different types of the MOSFETs. We have seen the enhancement type and depletion type MOSFETs, and again in the enhancement and depletion, we have P type and N type, and we have seen the symbol. So generally how we can write is, so as you can see, we can write the symbols for this also. We'll write the symbols for these transistors. This was the structure we have seen. So we'll see the symbol for this N-type and P-type transistors. You can see it has 3 terminals here. Okay, so this is gate, and you should remember one more thing: the source and drain terminals are interchangeable. Okay, so first we'll see the N-type MOSFET. So in the N-type MOSFET, so this is a symbol for the N-type enhancement type transistor. So if the arrow is towards outside, it is called as the N-type transistor. And in the P-type, okay, for the source only, the arrow if it is outside, then it is called as a P-type. And in the enhancement type, this is enhancement type. So in the enhancement type and the depletion type, the only one difference is that the depletion type, there will be channel will be established from the beginning, but whereas in case of enhancement type, the channel does not exist between the source and the drain terminal. So that's it for the today's presentation. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.